In this section, we're going to talk about a very important property that is frequently used throughout the algebra course. It's known as the distributive property. Let's try to understand how the distributive property works. So we are going to begin by considering three numbers. Let A, B, and C be three numbers. Now, the distributive property states that if we take, let's say, consider the number A, and we multiply it to the sum of B and C. Now, what we're going to do here, we're going to distribute A to each of B and C, and that can be done by, first we are going to distribute A with B, and then we're going to distribute A with C. So this is going to give us A, since we are multiplying, distributing also means we are multiplying the terms. So we have A multiplied to B, so that's going to give us AB, and that will be added to the product of A and C, or we can say A distributed to C, A times C. So this is the distributive property. Now similarly, we can also have another case where A is, let's say, multiplied to the difference of B and C. So that's when we apply the distributive property. So okay, A gets first distributed with B. So that's going to give us A times B minus, so we have a minus sign here. So this is going to come here, the minus sign, minus the distribution of A with C. So that's simply the product of A and C. So this is called the distributive property. Now we can even extend it to more than three numbers. So let's say we have another number D. So let's say A is distributed to a series of operations that's happening within the parentheses. So let's say B minus C plus 2 times D. So the distributive property, when we apply it, it means we have to distribute A to each of the terms within the parentheses. So A distributed to B means we write the product of A and B, so that will be simply AB. Then we have a negative sign here, so we'll write the negative sign. Now A will be distributed to C, so we'll have A times C. And finally we have so the positive sign comes, we have A distributed to 2D, so we have A times 2D. So that gives us AB minus AC plus A times 2D. So this is how we can use the distributive property to manipulate a given expression, a given algebraic expression. It can be also used to manipulate arithmetic expression. So let's do one example. So the first example that we're going to do will involve an arithmetic expression, and I'm going to show you how we can apply the distributive property to find the answer. So in the first problem, we are provided with an arithmetic expression 6 multiplied to the sum of 4 and 5. So we have to use the distributive property and find its value. However, we have already performed such kind of operations in the previous section. We have used the order of operation to find out the value of such an arithmetic expression. So let's figure it out what's the value of this given expression is. So here we have 6 multiplied to the sum of 4 and 5. So we know that we always have to work out the operation within the parentheses. So we have 4 added to 5, which is present within the parentheses. So that's going to be 9. So that means we have 6 multiplied to 9, and 6 times 9 is 54. So that means our answer should be 54. Now let us apply the distributive property. So first we are going to distribute 6 to 4, so we rewrite it as 6 multiplied to 4, or the product of 6 and 4. That will be simply 6 times 4. Then we have the plus sign, so we write the plus sign here, and then we are going to distribute 6 with 5, so that's simply the product of 6 and 5. So 6 times 4 is 24 plus 6 times 5, which is 30. So 24 plus 30 is going to give us 54. So when using the both method, by using the order of operation and by using the distributive property, we have arrived at the same conclusion, that the So the product of 6 multiplied to the sum of 4 and 5 gives us 54. Now this particular example looks very counterintuitive, that we could have gone simply with the property of order of operation and found out the value faster. Why even bother using the distributive property? Now let me show you with another example why this property is very powerful. Let's say we have a number, let's say we have 7 multiplied to let's take 17. Now instead of multiplying 7 to 17, what we can do here is we can rewrite 17 as 20 minus 3. So that's the same thing as 17. Now we're going to apply the distributive property. We have 7 multiplied to 20, so that will be 7 times 20 minus 7 distributed with 3, so that will be simply 7 times 3. So 7 times 20 will be 140 minus 7 times 3, which is 21. So that's going to give us 119. So this is way faster than simply multiplying 7 with 17. So we can always use the distributive property to find out the value of the given arithmetic expression in the fastest way possible. Now in the next example, what we're going to do is we're going to consider an algebraic expression and then see how the distributive property works for such expressions. So in this particular example, what we have is we have 6 multiplied to the sum of x and 5. So here x plus 5, this represents an algebraic expression. So let's apply the distributive property and see what its value going to be. So first we are going to distribute 6 to the first term, so that is x, so that will be simply 6 multiplied to x, so that gives us 6x. So we have a plus sign here, so we put the plus sign, and then we are going to write the product of 6 and 5 because we have to distribute 6 with the second term as well. So 6 times 5, so we have 6x plus 6 times 5, which is going to be 30. So that means the given expression 6 multiplied to the sum of x plus 5, x and 5, so this is equivalent to saying we have 6x plus 30. So this we have obtained by using the distributive property. Let's do another problem. So in this particular question, we have an algebraic expression which is slightly complicated compared to the previous problem. However, it's a very simple one. We will solve it step by step. So what we have here is 6x multiplied to the sum of x squared and 5 times x. Now what we're going to do is we are going to use the distributive property, and we're going to write out the first term. So the first term will be, so we're going to distribute 6x with x squared. So that will be simply 6x times x squared. Then we put the plus sign here since we have a positive sign here. Then we're going to distribute 6x to the second term. So that is simply the product of 6x times 5x. Now 6x times x squared. So what we have to do here is we have to use the laws of the exponents. So we have x, laws of the exponent. Let me write it down here. The laws of exponents states that if we have x raised to the power of a multiplied to x raised to the power of b, so that is equivalent to saying x raised to the power of a plus b. So here we have 6 times x. So we have a here is equals to 1 and b is equals to 2. So we have the equivalent expression will be x raised to the power of 1 plus 2 plus 6 multiplied to 5 times x raised to the power of, so the exponent of each of x and 6x and 5x is 1. So we have x raised to the power of 1 plus 1. So that's going to give us 6 times x raised to the power of 1 plus 2, so that is 3, plus 6 times 5, so that's 30, times x raised to the power of 1 plus 1, so we get 2. So this is the simplified expression. We have 6x cubed plus 30x squared, and that has been obtained by using the distributive property. Let us do another problem. So here in this question we have another algebraic expression. Now this particular expression has got several terms, so we can count that. So here we have the first term, this will be the second term, and this will be the third term, and each of the terms are multiplied by negative 5x squared. So we have to use the distributive property to simplify this given algebraic expression. So let's begin with the first term. So to find out the first term, what we're going to do, we're going to multiply negative 5x squared to the first term, which is x cubed y squared. So that's going to give us negative 5 x squared, so let's put it within parentheses, multiplied to x cubed y squared. So this will be our first term. Then we have the second term. So the second term, that involves a negative sign here. Now we have this negative sign comes from the fact that we have a negative in the second term, negative sign. Now we're going to multiply negative 5x squared. So this negative 5x squared is going to get multiplied to the second term, which is 5 of x. So we have negative 5x squared multiplied to 5 of x, plus to find out the third term, so we take negative 5x squared and multiply it to the third term, which is 2, the third term within the parentheses. So that's going to give us, so we further simplify this, so we're going to separate all the like terms, separate in the sense we're going to write all the like terms together. So here we have only a number which is negative 5, so let's write it in the beginning, followed by x squared times x cubed and multiply to y squared. Then we have negative of negative 5, so negative of negative 5. So first, okay, we'll work out with it in the next step. So we have negative multiplied to negative 5 times 5 times x squared times x, plus negative 5 multiplied to 2 multiplied to x squared. So we have now for the first term, so will be negative 5 multiplied to x. Now here we have 2x, so one has a power of 2 and the other has a power of 3, so the exponents will get added. So we have x raised to the power of 2 plus 3, and that will be multiplied to y squared. Now since x and y are totally different variables, so we cannot add up the exponents, so it's going to stay separate. Now we have negative times negative 5, so negative times negative 5 will be positive 5. So positive 5 multiplied to 5 will be positive 25, and multiplied to x raised to the power of 2 plus 1, the exponents of x will get added, and then we have positive multiplied to negative 5, so that will be negative 5, and we have negative 5 multiplied to positive 2, so that's going to give us negative 10x squared. So finally we're going to get negative 5, so x raised to the power of 2 plus 3, so that will be 5, times y squared plus 25 times x raised to the power of 2 plus 1, so that's 3, minus 10x squared. So this is the simplified form of the given expression, given algebraic expression. So negative 5x squared multiplied to x cubed y squared minus 5x plus 2, so that's going to give us negative 5 times x raised to the power of 5 times y squared plus 25x cubed minus 10x squared.